Now let's see the question from chapter 15, structure of atoms and nuclei. It's a board question for 3 marks. Write a note on nuclear fission and nuclear fusion. It was in the board examination for 3 marks and the date is October 2013. Now let's see the answer for this. So nuclear fission first. So let's see what is nuclear fission and one example we can see. So basically, nuclear fission and fusion, these are the two processes which occurs because to attain stability. Now, see here, what is nuclear fission? The phenomena of splitting of heavy nucleus into smaller nuclei with the liberation of energy is called as nuclear fission. So simply, one heavy nucleus is separated into two lighter nucleus, two or more lighter nucleus. And this process, in that process, energy is released and it is called as nuclear fission. Means heavy nucleus separated into two lighter nucleus. So that process is called as nuclear fission. Now, in that process, if you find out the mass of this daughter nuclei, means if I consider two daughter nuclei are, then if you add the mass of these two daughter nuclei, and this mass is always, or we find it is less than the parent nuclei mass. Now, why the difference in the mass? Because the difference in the mass is converted into the energy. Why we get energy? You know that mass energy relation, Einstein's mass energy relation. You know that mass, the missing mass here is converted into energy. Now let's see example here. You can see here when this neutron is bombarded on a uranium. Let's see the reaction also here. You can see. So this is uranium 235. On this uranium 235, this neutron is bombarded. Then this uranium split up into two products. So first one is barium and second one is krypton. And three neutrons are released. You can see the neutron 1, neutron 2 and neutron 3, as well as energy is released in this process. You can see this reaction. One neutron is bombarded on this uranium, then it's separated into barium and krypton. And three neutrons are released with the energy. So this is nuclear fission. This nuclear fission, in that nuclear fission, we can say that energy release per nucleon is 0.9 mega electron volt. So total energy is 200 mega electron volt. And how many nucleons are there? 235. So if you divide 200 by 235, we are getting approximately 0.9 mega electron volt energy per nucleon. Now here, this reaction is possible at normal pressure and temperature. No condition, special condition of the temperature and pressure here. Similarly here, you remember one thing here. Percentage of the mass converted into energy is 0.1%. So only 0.1% mass is converted into energy in this nuclear fission. Now, similar manner, let's see the nuclear fusion also. But before that, you remember, so whatever the binding energy per nucleon this uranium has, and this barium and krypton. So here, after separation of heavier into two lighter, binding energy per nucleon of this means binding energy per nucleon for this barium and krypton is more than the uranium. In simple word, we can say that this reaction is occurred to attain stability. More the binding energy per nucleon, more the stable nucleus. Now, after that, nuclear fusion. Now, when two or more unstable smaller nuclei join together to produce one stable nuclei and energy is released, the process is called as nuclear fission. Here, so remember, in the fission, heavier split up into two lighter, but here, two or more smaller nuclei join to form a one stable nuclei. Again here, this reaction or this process to get a stability. Now let's see a reaction here. So when hydrogen combine to form helium, then energy is released here. So when hydrogen combine to form helium, energy is released. But if you see this is a smaller nuclei. Both are the smaller nuclei. So energy released is about here uh, 20, 26.7 is the total energy. And if you see the per nucleon energy, it is 6. So basically, if you divide 26 by 4, then it is coming near about, this is approximate value, 6 mega electron volt per nucleon. This is the energy released. This has a more energy per nucleon than fission. So in fission, this is 0.9. As compared to 0.9, this 6 mega electron volt per nucleon is a very larger. Then after that, you remember one thing. Nuclear fission, this nuclear fusion process occur on the surface of stars. So the energy, sun energy we are getting from the sun, it is because it is a result of this nuclear fission. So this reaction occurs on the surface of sun and we get a sun energy. Okay. Now listen, here you can say that hydrogen nuclei are fused to form helium nucleus and energy is released. So fusion reaction can take place in the surface or on the surface of sun. And you know that, so on the surface of sun, high temperature is there. So you note one thing here, to occur this nuclear fusion, we require high temperature and pressure. Now, we learn here nuclear fission, nuclear fusion. Now let's see the distinguish between nuclear fission and nuclear fusion also in one go. So you can see here nuclear fission on one side and nuclear fusion on another side. Now, in nuclear fission, neutrons are required. We learn a reaction where uranium is bombarded by neutron, then only it is split up into barium and krypton. So neutrons are required. So here in nuclear fusion, proton or deuterons are required for it. So it is possible, nuclear fission possible at normal temperature pressure. But nuclear fusion is possible at high pressure and high temperature, that you remember. Energy released per nucleon in the nuclear fission is 0.9 mega electron volt. But in nuclear fusion, that energy is very large, about 6 mega electron volt, or about 7, you can say that, 7 mega electron volt. Now here, percentage of the mass converted into the energy in nuclear fission is near about 0.1% only. But here, in nuclear fusion, lighter nucleus are there. So maximum mass is converted into the energy. So here, the percentage of conversion of mass into energy is 0.7%. As well as you can say that nuclear fission uh, is occur in case of uranium. Uranium is very expensive. So fissionable materials are expensive, we can say that. And nuclear fusion, we learn hydrogen. Hydrogen combined to form helium and larger energy is released. So this material is a fusion material, we can say that they are cheap. So this is a distinguish between nuclear fission and fusion. So one more point you can add here, in nuclear fission, a heavier nucleus split up into two lighter. And in fusion, a two lighter combine to form heavier nucleus.